This is the solution to question 4 on the DeMoivre's theorem tutorial sheet. The question states that we should consider the expression cos theta plus I sin theta to the power of 4 and use this to express tan 4 theta in terms of tan theta. The first thing that I'm going to do is consider writing C is equal to cos theta, S is equal to sin theta, and T is equal to tan theta. This will help later when we have some very large expressions involving cos, sine and tan. Now the questions suggest using cos theta plus I sin theta all to the power of 4 and investigating what will happen with this expression. So that's the first point I'm going to consider. C plus IS all to the power of 4. Now I'm going to use the binomial theorem to expand this particular bracket, and if I do that I get this particular expression here. I haven't tried to be clever and simplify the expressions involving I, because these are very common sources of error. Now the expression involving just the I term can't be simplified further. I squared is equal to minus 1, I cubed is equal to minus I, and I to the power of 4 is just equal to 1. Using this we get the following expression. Now this is as far as we can go simplifying the bracket at the moment. We are dealing with a tutorial based on DeMoivre's theorem, so at some point we would expect to have to use it. So I'm now going to write out DeMoivre's theorem in a way that perhaps might be useful in the question. In particular, cos theta plus I sin theta to the power of 4 is equal to cos 4 theta plus I sin 4 theta. We can now use this to rewrite our expanded bracket. We get cos 4 theta plus I sin 4 theta is equal to cos to the 4 plus 4i cos cubed theta sin theta minus 6 cos square theta sin squared theta minus 4i cos theta sin cubed theta plus sin the 4 theta. Now the left hand side and the right hand side contain real and imaginary parts, so what I'm going to do is equate those. Equating the real parts gives us the following expression for cos 4 theta. Equating the imaginary parts gives us the following expression for sin 4 theta. Now we want an expression for sin 4 theta. So what we're going to do is write tan 4 theta is equal to sin 4 theta over cos 4 theta. And the most obvious thing to do at this particular point is substitute in the two expressions we had previously. At the moment, the right hand side of this expression does not involve tan theta. So somehow I need to get the right hand side solely in terms of tan theta. The best way, and in fact the only way to do this, is to divide top and bottom by cos 4 theta. The reason for doing this is that it eliminates all the coses in a way that leaves only sine over cos, sine squared over cos squared, or sine to the 4 over cos to the 4. And in this particular way we end up with 4 tan theta minus 4 tan squared theta, all divided by 1 minus 6 tan squared plus tan to the power of 4. And we have used these particular facts, that S over C, which is of course sine over cos, is equal to tan, sine squared all over cos squared is equal to tan squared. And that completes this particular question.